or what's the other one? WhatsApp would be good examples of this. We are a backend database product, so we have not sort of decided any rules at all about your front end. So you can build anything you want in the front end. We recommend that you build some sort of web front end, but if you're into building native applications, those will work too. We imagine you'd need some sort of web sockets to receive notifications from the backend when things happen. And the main aim of this challenge is to use Redis, which is a product that you might have heard of as a cache and something that's ephemeral. So it stores all the data in memory, and then when you reboot, you lose it. But you're going to use it as a persistent primary data store, which it's also very good at being. So to help you be successful and get you set up quickly with this, we've created a pretty complete GitHub repo that contains a Dockercompose file for setting up with Redis and the Redis Search module that we'll use, and I'll cover what that does in a minute. And also instructions for how to sign up for our cloud service if you want to do it on there and not use Docker. So there's two ways of getting a database, which is like the essential thing you need for this challenge. You can use Docker or you can use Redis Enterprise Cloud. There's links to that, but Enterprise Cloud is simply a sign up. What you get is a 30 megabyte Redis instance, and you can choose the Redis Search module, and we provided instructions for that. The two are completely equivalent, so use whichever one you like to do. What we've done in this README is we've provided some sample data to show you what we think the data model should look like. And we've provided a data loader for that. And I'll run through how that works and some sample queries. So when we are able to get the data into Redis, we'll be able to make queries that you might not think are possible in a key value data store. So normally the way a key value data store works is that it would store data against a key. And if you know that key, or you can infer it, or you can figure it out from something, then you can access the data. With Redis Search, we'll be able to access data in a more sort of SQL database type way. We can write queries against non-key fields and get things back. So if I index my users by username, then I will be able to get Simon back if that was my username. But I wouldn't be able to ask it questions like, find me all the users that are based in Nottingham, England. And with Redis Search, we can. So the Redis instance we provide in Docker has Redis Search built in. And the cloud module, the cloud database, has the ability to install that too. So what we've got here is a repo that you can clone, and you're going to need to do that to get the sample data and go from there. So what I'm going to do is show you how to do that. I've cloned it here already, so I just git clone this. And there's a bunch of files in here, one of which I'm going to go the Docker route for this demo is the Dockercompose.yaml. And what we're going to do with that is start a Redis instance. So I'm going to do Docker compose up, and I'm going to do -d, which basically means I want terminal to come back to me and it to start in the background. And I will just quickly deal with that. So that's started, and we should now have a Redis instance running, and it'll be empty. So there's a couple of ways I can connect to Redis, one of which is with the Redis CLI tool, which is like a command line. And I can ask it, hey, Redis, what keys do you have? And we have nothing. It's an empty database. So I need to load some data into that. What we've provided you with is here in the data loader folder, we have a node package that is going to load some sample data into there with some example messages, example chat rooms, and example users. And if I do npm install to get the dependencies for that, then it will, then when I do npm start, it'll go away and load some small set of sample data and also do some checks to make sure that that was okay, so that the data made it into your instance fine, and that you have the Redis Search module correctly configured, which as long as you checked it in the cloud or used our Docker image, there's no configuration to do. So what have we got now? I can use Redis CLI and again do keys and ask it what's in here. We now have a whole load of different things. We have some users, we have some messages, and we have some channels. And another way that you can look at data in Redis that will be very helpful for speeding up your adoption of this in this challenge is to download Redis Insight. So Redis Insight is a graphical tool, and I have it up and running here. You download it and install it, and then it presents a web interface, and you can connect to Redis instances. So here I'm connected to the instance I have in Docker. And what I can do is, instead of dealing with a CLI, I can have a browser here and I can click on things and see what we've got. So if I look at user:Simon, I can see that that is a Redis hash, which is a data structure that models a flat object of name value pairs. And I can see that in there, we've got information about me. So my first name, last name, city, country, and what my username on the system is. We also have channels in the data set. So we have a Redis set here, which models a mathematical set. And this tells us what channels are available in our chat clients data set. So we have a random channel, a tech client channel, and a cricket channel. And then for each of those channels, if I click on one of those, channel:cricket, that's what's called a stream in Redis. So it models an append-only log. It's a time series sort of data stream. And I can click through here and we can actually see what's in there. So what's in there is actually a load of timestamps and a field called type. And the value in this case is always message. So whenever someone chats in Cricket, we add a timestamp of what they do in that. And we store that a message was recorded at this time. And then if we want to get the value of that message, so the one that ends in 744-0 here, I can go back to my browser and there'll be a key called message : and then there we go, that's it. And this is itself a hash in Redis. So it's another instance of that hash data structure. And we are storing who posted the message. So I did, what channel it was in, Cricket, and my message. So I said, fantastic cash to win the game too, in whatever conversation I was having at this point with somebody. So we have got sort of 2 or 3 entities in the data model here. We've got users, which are models of a hash, and we've got messages, which are modeled in 2 places. So they're in a stream and in a hash. So the stream is designed to store the sort of order of messages, and the hash is going to store the details of those. We also have channels. So channels is basically a set containing all of the available channels. And you could use this, for example, to build a channel browser. So what channels are there? You don't have to go querying Redis and ask it every key has it got and then figure out which one's a channel key. You just have to go and say to the set channels, give me all of your members, and we'll look at how to do that. And then we have a similar set for usernames, which is these are all the usernames that are currently on the system. So if you were signing up a new user, for example, you want to check that their username wasn't already taken by asking Redis, hey, is that username in this set? And it will say, yes, it is, or no, it isn't. So we can see how that's going to work for us by doing some queries and running some Redis commands. And as I said before, the Insight tool is optional. It's kind of like Candy for having a graphical user interface. You can do everything as well back here in Redis CLI. If you don't have Insight or you don't want to download it, and if you do use Insight, you can use the browser, or you can flick to the CLI view here, and you can add Redis. You can run Redis commands here too. So, for example, if I wanted to ask Redis what are all the usernames on the system, so I'd say s members, which is the Redis command for get all of the members of a set. And you'll see I've got some sort of help here. So it expects a key name, and my key is usernames because that's where we stored it. Then we get back all of those members. Now, obviously, you're not going to do all of this in a command line interface. You're going to build a backend that has API routes that does these things. So in order to do that, you'll need what's called a Redis Client, which is equivalent to a Redis database driver for your language of choice. So we've provided some help and resources for Node.js, but if you're more comfortable in another language, feel free to go ahead and use that. There are Redis clients for pretty much every language, and you can find them at redis.io/clients. So you see here, there's quite a lot of language choices. And then if we pick a language that's not Node.js, so I go ahead and pick, say, Java here, you'll see that there are multiple choices of client for the Java language. And I would recommend you pick one of the ones with the star here, because these are like community recommended clients. So the Redis client is a good one to start with if you were to go with Java. For JavaScript, Node.js, we've provided examples with the IO Redis client. So imagine I wanted to run some commands here. So like get all user Simon, which is get everything out of the hash in user Simon. So this would be an API route for get Simon's profile. I get everything back here. We can take a look at how that works in Node, and we've provided some example code for that I will just make a lot bigger. So the way that you're going to work with Redis in a programming language, and this applies to most languages, we just pick Node, is you do whatever you need to do to require or include the Redis driver. So in this case, we're just requiring something called IO Redis, which is a client for Redis. And we're creating an instance of it. And as you'd expect with many database products, we're having to tell it what host, what port, and whether we've got a password to connect to. So by default, it's going to connect to localhost 6379. That's where Redis runs, and that's where the Docker client runs. If you're running our cloud Redis product, you'll get alternative values for these things when you set that database up, and you can set them accordingly. Then all we're going to do with that client is basically call the same functions as we have the names of Redis commands. So if you look up or know a Redis command, so we want hgetall, for example, I've got some code here that is just Redis client dot hgetall, and then the key that I want to get. So what's happening here is we're telling the Redis client, go away and talk to wherever Redis is, get the hash at user:demo, and return everything to me. So in that case, that will be returned as an object. It'll be in user info, and then I can do things with it. So I can log that out. And we've provided this demo script that just shows you some of the basic things that you'll need to do with the system. So in order to be successful, you'll need to be able to add a new user. So there's a demo of how to do that. We basically create a user's profile as an object. We add the username to that set of usernames. And we then store that username in Redis as a hash, or store that object in Redis as a hash. And then when we want to get it back, we use hgetall. And then when we want to do a chat message, so someone chats on our system, we have like a two-step process. They might be creating a new channel. So we basically say to Redis, add the channel name that they're chatting into the set of channels. Doesn't matter if it exists already, because it's a mathematical set, it will deduplicate it. So if every time we add tech, it's only going to be in there once. So your channel list won't get full of text. So you don't even need a separate like if case for if this channel exists already, then don't add it. You can just go ahead and add it. It's safe. Then what we're saying is, hey, Redis, add a new message entry into the stream for that channel. So we use something called the xadd command, and we've provided the documentation for that and sort of background information on that. And Redis will give you the timestamp that it's added that for. Then we're going to use the timestamp and make that part of a Redis key. So we're going to do message:timestamp. And in that, we're going to store an object that looks like this. And in our README, we've provided the schema for these things. So here in the README, you have a set of use cases, information on how to get up and running with Node, as I've kind of shown you very quickly. And we'll cover search in a moment. But if I pick, for example, one of these, how to register an account, we have all the Redis commands that you're going to need to use in whatever language you choose. We have the schema of the hashes that you're going to create in Redis, or you can use the example data to check that out as well. And then we have a walkthrough of the process for doing each of those. So as you build your application backend, you can build out these use cases, whatever front end you're interested in. So one thing that I wanted to show really quickly was everything we've done so far with Redis is like with key names. So it's key value data store. So I can retrieve something if I know the key for it. So if I want to get what channels there are, I can do basically s members channels and get all of the channels. We have those. And then if I want to get everything from the tech channel, I can, for example, use what's called the xrange command. This queries a stream between a given set of timestamps. I'm going to say I've used this format for the channel names. So we know that there's a channel called tech because it was in our list of channels. And then I'm going to say from the smallest timestamp to the biggest timestamp, just tell me what's in the stream. And we get two messages there. So there's two timestamps. And if I look at one of these and I want to see what's in that message, I know that that's in a Redis hash because our schema says it is. And I can do hgetAll message, which was the prefix that I used for messages, and then that. And it's a message from Ada saying that she's really excited for the new Redis release. So all of that was working because we were able to figure out the key for everything we needed all the way. But what if, for example, I wanted to answer a question such as there's a user called Wazim on the system, and I want to know everywhere he's posted a message. So this is where the Redis Search module comes in, and we are going to see how that works. So that's going to do queries over the usernames and the messages. So we've created a couple of indices in here for you, one for messages, one for usernames, and these are documented along with the fields in them. So if I wanted to, for example, find everything Wazim has posted, we do ft.search, the index name, idx messages, and then my query, which would be, I want everybody with the username of Wazim. I want everything from the username Wazim. So we can see Wazim here has posted a couple of messages, one in the tech channel and one in the cricket channel. And this is quite powerful because we're not indexing messages by username. And normally that would be a problem in a key value data store, but this allows us to write queries over non-indexed fields. So if, for example, I wanted to find all messages from Wazim or Simon, so myself, and I only wanted messages that were in the cricket channel, I can make a query like this that says find everything where the username is either Wazim or Simon and the channel must be cricket. And then you'll see we get a couple of messages back where we've been talking back and forth about cricket. So a couple of questions. Hamza asks, what type of app do we have to make? Anything, as long as it's a chat app. So it could be native application front end for a phone. It could be a web application, which is probably the fastest thing to make. It could be, I don't know, voice app for Alexa. We would love to see what you come up with, and we're mostly interested in making sure that I can help you understand how to use Redis and the documentation can. So we'll be looking for, a sort of fun and interesting front end and some chat app features, and we've listed those out in the README. And we'll be assessing those use cases and how you've used Redis, possibly more than, say, the design of your front end, because we're a database product company, we're not a front end company. Somebody's asking what happens when the username set is removed. Does it remove other things? Not unless you make it do so, no. So there aren't relationships here. So if we look in the keys that I've got a set usernames here, and that includes Wazim, Yaz, Antiras, the guy that invented Redis, myself, and some other people. And each of us has a user : username hash. And there's no relation between these two things in Redis. It's kind of on the developer to remember what these things mean. So if I were to remove a message or remove a user from the system, I have to do two things. I have to do srem usernames. Let's remove myself. So let's remove the entry Simon from the username set. So now I'm gone. But if I do hgetAll user Simon, that entity is still there because there's no relationship between these two things that the database is enforcing. So to do that, I just do del user Simon, and now I'm completely gone from the system. So one thing to notice with that is that we were indexing this with Redis Search as well. So now I've deleted that. I won't be able to find myself in the users index because the indexing will auto update for us. So while the entities aren't related, the index is managed for you and you don't have to update that. So Apple asks, what happens when I set a key twice? Does it get overwritten? Yes, it will. So if I do, for example, just set a simple string, set Simon test, and then get Simon, we can expect to get test back. And then if I do set Simon new thing and get Simon, we get new thing back. The other thing to note here is there's no implicit create step for a lot of things in Redis. So if I'm creating something, then I normally create it by just adding the first thing to it. So if we were to have a new channel called, I don't know, tennis, let's do something like add channels tennis. So add tennis to our overall list of channels. So it shows up in our channel list front end. And then I could do add a message to that. So xadd channels tennis. This key doesn't exist, or channel tennis. This key doesn't exist in Redis. Redis has no idea what it is. And then I can say, Redis, I want you to give me IDs for things in this channel. And I can do, I want to add a message, which is just a pair of strings that we're adding. I get an ID back. And we now have a Redis stream that's called channels tennis. So if I look in the streams view here, or channel tennis, I can search for that. We'll see I have one timestamp, but I didn't ever dimension or create this stream. I just added to it and we got the thing. So people are also asking, how do we compare Redis with Firestore or other mobile databases? I'm a little bit biased. So Redis does kind of things fast. It's a data structure server. The whole data set lives in memory and it is persisted. But the fact that it lives in memory means it's going to be very, very, very fast. Redis also has a sort of eclectic grab bag of data structures and is extensible to include things like JSON documents and a search index. And I don't know how you'd search Firestore. I do have some Firebase experience, but it's a little bit old, so I wouldn't want to comment. I would say Redis isn't an overall platform. You know, we're not a hosting platform or things like that. You're not going to put code in there and run your application and host web pages on there. We are a data store. And if you did want to do some scripting, you can write Lua scripts and put those into Redis and have it execute them for you, but not in the same way that you would with, say, a Firebase product. If you're using Redis as a database, can you make complex queries on databases like joins and aggregations? In this application, you can basically use the Redis search module to do a couple of things here. So here's a username, it's a hash, it's an object-like structure. There's no fixed schema on this, so I can add another field to this hash and it won't appear in any of the other ones. I have to manually go and add that if I want to. And then using Redis search, I can make queries over these fields that you wouldn't normally be able to do. So normally I'd have to know the key. And Redis Search does two things. It's an indexing and query engine, and it's also full text search. So I could find names that are like close to Steve or begin with STE or don't contain Steve, as well as other sorts of query. And what you'll see, let's see, here in the data loader, and we've documented this in the README as well, is it's going to create a couple of indexes. So we're creating an index on messages here, and we're saying to Redis search, watch the hashes that have the prefix of message and index them so that the username is a tag, which is like a unique field. And it's sortable, and the other things are mostly tags, but the message is text. So you'll be able to do full text like Elasticsearch type queries on there, and the query syntax for that is linked to the README. Is Redis good with large data sets? Yes, the sky is basically the limit for how much memory you've got, and all Redis commands have, if we go to redis.io, have their time complexity against them. So if we look at, for example, sets, and I use sadd, you'll see that the time complexity is big O of 1. So the bigger my set gets, the time complexity for adding to it doesn't get worse. It's just a constant. And that's the same for lookups. Redis is very much optimized for this sort of thing. The data is represented in memory, and actually in the background, as your data set gets bigger, it will rejig that representation, but it doesn't affect how you query the data store. So I don't know how we're doing for time here, but I think we might be about on our time limit. But basically, I would encourage you to be active in the Slack, and I'll try and help you out over the course of the hackathon. We also have a remote-based hackathon channel in the Discord, which is the Redis Discord, and that will live on after this. And this is an ongoing Redis community that we'd encourage you to join. Sorry, somebody's asked, there are multiple managed databases out there similar to Redis. Yeah, most of those are actually Redis underneath. So Google Cloud Memory Store, AWS Elasticache, etc. The difference between the Redis Enterprise Cloud and the Docker container we've got here is that search module. So you'll only find the search modules in Redis Inc. Redis, which gives you that ability to do the extra querying and functionality. But yeah, there are other implementations out there that are all based on open source Redis, and they're managed by the cloud vendors. And really quick, what would be the approach to manage security rules? You've got an instance of Redis 6 here, and in Redis 6, we added access control. So you can, let's just quickly do this. You can basically set up roles in here, and you can limit what commands, what roles can use, and each role can have a different password, and you can set up users that have those roles. Whereas before Redis 6, Redis was kind of like a, once you've got the password, you can do what you want. So thanks very much, Hamza.
Thank you so much, Simon, for addressing all these questions, and for actually sending this detailed documentation over the GitHub. And then of course I loved the video that you recorded to explain those challenges on the YouTube itself as well.
Yeah, thanks. And of course the aim was to try and get people not scared of learning a new database technology in such a small timeline for this event, and that's where we can help you with. So we tried to give people as much help as they can to start with.
Yeah, of course. And I still see there's a lot of questions. I think we can take them to the Slack channel. Of course, even me being a mobile application developer itself and working on a chat app, I also have tons of questions to ask you, especially about the pricing structure at Redis for startup level applications. But would love to ask them in the Slack channel. And thank you so much again for your support and for being here for this presentation.
Yeah, if we've got 10 seconds, I'll just take the Atomicity one. Someone says, how do we manage Atomicity? You can do optimistic locking and send a load of commands at once to Redis, and it'll tell you if a key changed during that. You can put your logic into Lua scripts in Redis, and they'll run atomically. And also Redis itself is single-threaded, so individual commands run essentially atomically by default because there's no or very little multi-threading in Redis, which is actually an advantage, even though it seems like it isn't.
Yeah, of course. And yep, I think we're right on time. And let's just thank you so much again for your time and for supporting at this Hackfest. Take care.
I'm based in the UK. I'll be around for a while on the Slack, and I'll try and look in on it on the weekend. Thanks.
Yeah, for sure. Thank you so much, Simon. Again, take care.
Thank you. Bye.
Bye.